Hi everyone. I hope I'm audible. Can someone in the Zoom can confirm if I'm audible? Hello, am I audible? Okay, thanks. Okay, so today we will talk about the week 4 lectures and some of the lectures which we have not yet covered in week 3. For the same, I will share my screen. Let me share it. For the same, again, I have created a Menti. So let's just hope. Mm, mm, okay. Yeah. So, whenever you have any doubt or any question which I will ask, you want to answer it, you can answer it here. So, I request everyone to just scan this QR or just go to menti.com or add this code, enter this code so you can join. Mm. So, are you not able to join this? Because no one is yet joined. I hope now you can able to join. Some error here. Wait a second, I'll just resolve this issue. Okay, now is this resolved? So you can join now using the same QR. Yes. Now you can join and you can ask your doubts in this using can join using this QR and go to menti.com or enter this code. Either way, it's fine. And you can ask your doubts here. In between, if you need, you can again scan this QR and join. Okay, people are joining. Let me wait for 1 minute here so people can scan and come. So you can just type your doubts here and ask whenever in the session, and I will look into it. Okay, so let us start. Okay, so today we'll start with week 3 session that we have left with is box and cat. So let me explain what's the game is. So there are n number of boxes. For example, in this there are 3 boxes in which the cat is hiding in behind one of the boxes, and whenever you pick up a box, the cat will, if cat is there, then you have found the cat, congratulations. But if your cat is not there, then the cat will move towards the adjacent box. So let's say if the cat was in the first box here, then if you open the box, let's say 3, so cat, you have not found the cat. So now the cat from 1 will move towards 2. Now the cat is present in the second box. Let's again think we open again the third box. Then again the cat will is not there in the third box. The cat will move towards from 2 to either to 3 or either to 1. It's her wish or his wish wherever the cat wants to go. So cat will only can move to its adjacent. So cat can't move from 1 to 3 or 3 to 1, but cat can move from 1 to 2 or 2 to 3. Okay. So now we want to find the cat in the more minimum number of questions we can ask. So let's say there are 3 cats. Now in the first, I am saying there is cat somewhere behind 1, 2, 3, and I will answer you the cat was there or not. So let me ask, where do you first will ask where the cat is? Like what's the first guess you will take? Which box number you will ask? You can write your answers in the same Mentimeter. Like what is the first box you will ask? Any suggestions? Like will you ask box 1, box 2, or box 3? Like how can you minimize your number of questions? I hope you have understood the game. If not, then you can also write, I can explain again. Um, you can type your answers if you have any. Okay, prop box 2 twice in a row. If you don't find the cat, then the cat is cheating. Okay, so I assure you that the cat is not cheating. Okay, so one answer is to prop box 2. Explain again, please. Okay, I will explain it again. So there are three boxes in which behind these three boxes, one cat is hiding. So you want to find the cat behind these boxes. Now, if you ask, is the so you are allowed to ask the questions: is the boxes behind one? Is the cat is behind the box one? Is the cat is behind box two? And you will open that box, and if you see the cat there, then okay, you have win because you have found the cat. But if you have not found the cat, let's say in the box one, if you open it, you have not found the cat. So the cat now, if the cat is in the box two, then it will move towards to its adjacent boxes. So if the cat was in the day one was behind two, then it can move towards one or three. So it's their choice. Now again, in the day two, you have again the question to ask whether the cat is behind this box or not. So let me explain. Let's say if day one, let's say you know the cat is, like I know, sorry, not you know, the cat is at box two, but you don't know. So I know, but you don't know. You are asking the questions. So in day one, you'll ask, is the cat uh, behind box, let's say one? Then obviously the cat was not behind box one. Then I'll say no. And the cat can now have an option to move towards box one or two because they are adjacent to it. Adjacent to it. So cat now, let's say, moves to box one. And day two, you again have the same question to ask whether the cat is behind which box. So now I want to reduce these questions. Like how many these, like you are asking that if the cat is behind the box one or behind the box two. So I wanted to reduce these questions and find the cat as early as possible. So what will you ask? I hope now this is clear. The one of the answer he asked is कि I will ask in the second box twice in a row, and he can find the box he was claiming or she is claiming. So any other suggestions? Okay. Is there any other solutions you have in mind, or this is it, like just one? Or if you agree, you can say I agree with this box too. I hope someone who is asking with is this clear now. Okay, let me, chalo, let's start with the answer which is given to us, like box 2. Okay, let me. So the person who guessed is right. You will ask box 2 because if the cat was at, let's say, box 1 or box 3, any case. So if you the ask in the day 1 whether the cat is behind box 2 or not, So maybe the answer is no. But if the cat is was at box 1, then cat has only option to go to box 2, right? And if the cat is at box 3, then the only option to go to it is again box 2. So if in the first question you find the cat, then it's good that you have found the cat and you are, congratulations, you find the cat. But if you not, but then the only option for cat to be at is either at box 1 or box 3. So in the next day, the cat has already moved to box 2. So again, you will ask the cat whether the cat is behind box 2 or not, and then it will say yes. So in 2 days, you will able to find the cat if the number of boxes are 3. So let me increase the boxes. Let me say there are 1, 2, 3, 4, 5. Since you asked in this the middle box 2, so will the same strategy will work here? If we like ask behind box 3 again and again, will the cat is at box 3 or not? So will the same strategy will work? And if it is doesn't work, then why? Well, I have given the answer to it that it will not work. Then why does this not work? If we ask again box 3, you can answer your you can answer your things in the Menti quiz, whatever your answer is. Let me see in Zoom as well. If there are any answers. Okay, no. You can just go to ask questions and then type your answers there. Okay, so there is one answer. If we keep probing box 3 again and again, so if we keep probing box 3, then the cat can just swap between the boxes 1 and 2 or 4 and 5 equivalently and we will never find it. Yeah, exactly. So if we ask in the day 1, if the cat is at box 3, then let's say the cat is at actually box 1. Then the cat can move towards box 2. And if we ask again whether the cat is at box 3 or not, then the cat can again move towards 1. So it can again swap between 1 and 2, and we are keep asking at 3. So the same strategy will not work here. So let's start and analyze that how can we find the cat. Let's say we don't know the answer and we want the worst case scenario to find the cat. So let's start with probing with, let's say, 2. So let's ask at box behind 2 whether the cat is behind box 2 or not. So this we are asking. And for the worst case, we don't want to find the cat in the first scenario. So we want to find like how many questions we need to find the cat. Like after this, there is no scenario left. Cat, we can't able to find the cat. So and we don't want to ask any silly questions like this, like we are asking again 3 again and again whether the cat is there or not. So we want to find a good strategy. So let's ask behind the cat 2 whether the cat is behind box 2 or not. Let's say it's not there. Okay. So possibly the cat in the first day should be at 1, 3, 4, or 5, right? If the cat was not behind 2, then the cat must be at 1, 3, 4, 5. Now, If it is at 1, then it will be moved towards 2 because it's the only option there. If it's a box, if the cat is behind box 3, then it will have moved 2 or 4. If the cat is behind 4, then again 3 or 5. And if at 5, then again 4. Because cat can't move from 5 to 3. Now, see, there are only, let's say, again, then we check at 3. Why we check at 3 though? Because if you look at, if the cat is at, because of the even parity and the odd parity, so we ask the cat is at 2. Now we will ask the next cat whether there is not, it's there or not in the odd cat, in the odd parity. In the, and if you look at the answers, it can move towards 2, 4, 3, or 5, or 4. The only single option, like there are mostly answers for 2 or 4, and there is only one answer for 3 and 5. So let's rule out 3 and 5 first. Let's check at 3. Let's say, again, because we want the worst case, let's say it is not there. So if the cat is not at 3, then if the cat has moved from day 1, from 4, then it must have moved towards 5 and not 3, right? If the cat is not at 3. And in all the other cases, if we look at, there is no possibility that the cat will be from 1, 3, or 5 that it can move towards. So if initially the cat was at 4, then it moves to 5. So let's again consider, if the cat is at 1 in the day 1, then it can move toward, and then it will move to 2, and then it moves to, so in day 2, because we have not found the cat at 3, then if the cat was at initially at 2, then it will have gone to 1 or 3. Since the cat is not at 3 also, so 2 or 4 in the day 1, and it will move to 1, 3, or 5. And if the cat was at 5, then it was 4, 3, or 5, like in the day 2. So all the other cases, for if the cat is at, in day 1 it was at 1, 3, or 5, in the day 2 it would have moved to 2 or 4 or 4. So these are the possibilities. Then again in the day 2 it would have been to 1 or 3, 1, 3, 5, or 3 or 5. But if we have only ruled out this case, that if the cat is at 4, then it will move to 3. It cannot have moved to 3 because then we had found the cat. So if the cat was at 4, then it have moved to 5. So if it moves at 5, then the only possible case it can move to 4. Now, if we see, look at the parity, it has become all odd, but 1 is even. So let's check it 4 now. Because if it is not at 4, then we have ruled out that initially the cat is at 4. So if not, let's say again because we are looking at the worst case scenario, if so the cat is not at, is this also. So initially the cat is not, cannot be at 4 because we have not found the cat at 4. So it will not be have to move 5, and it has not initially at 4. So cat is initially at either 1, 3, or 5. So in day 1, if the cat was at 1, we have moved to 2. If the cat, because in day 2 we have also not found the cat, so it can have moved to 1 or 3. If it's not at 1 or 3, it have moved to, because 1 is adjacent to 2, or 3 is adjacent to 2 or 4, so 2 and 4. If we're not at 3, then again if we go at this, it will be 2 or 4, and 5 it will. So now it's all 2 or 4, 2 or 4, 2 or 4. So we can check it either 2 or 4. Let's say we checked at 4. Let's again, because in the worst case we want it is not there. So let's say it's not there. Then the cat has moved to, if it has not moved, so at from 3 it has obviously moved to 2 in these cases. So if it has moved to 2, then it will further move in the next day from 1 or 3. Now we have cornered the cat at 1 or 3. So if we check at 3, then we know that it is not here. So if the cat was at 1, then it only case it has moved to 2. So in the case we want that we don't want two options that the cat has moved to one or three, two or three. We want only one option at the end, so we did narrow it down and find the cat. So we will check at three. If we checked at one, then maybe if the cat was at three, then again it have moved to two or four, and again we have two options to ask. So we don't want that case. We want to reduce our cases, so we will ask at three, and then we know if it is not there, then checking at two will give the answer, because it will obviously will be at one, and then it would have moved to two, and we are done. And if you notice that in the six questions we have found the cat. I hope this is clear. Can you, if it is not clear, if you have any doubts, you can ask. Is this clear? Okay, there is no question in Zoom. If it is not clear, then I can once again repeat this. If you want, I can repeat. It will be nice if you like can interact, because then only I can understand if you are having any doubts or not. If you don't type anything, then I'll just assume that you have understood this. Should I repeat this if you have not understood? You can write repeat as well, and I can repeat. So, is this clear then? Okay. So if you have don't have any doubts, so if you have any and you're shy to ask, then you can again look at the videos which ma'am have given to you, and you can look at. Now this was at the odd case scenario. So let's move towards if the boxes are even. So if there are just two boxes, one or two, so I want to ask, in how many questions can you answer this? If the boxes are only two, this case. Can you find a box in two questions or in one question? One, like in the worst case, I meant to say, not or three questions. This is one question. Okay. Someone is saying one question. If it will be like helpful for me if you ask in the open question, like not in the live chat, because live chat goes away and I can't able to see your answers. It will be helpful for me if you can ask here. Someone has said one question. Yeah. How can, but one question is like you will determine the cat is at one question. but I think you will need two questions to finally find the cat. Because in the one question, if you ask if the cat is at 1, so you will know if the answer says no, then you know the cat is at 2, and now it will move towards again 1. So you will ask again 1 whether the cat is here or not. So I think the answer should be two questions and not one. I hope this is clear, whoever's written one question. That if you ask question number 1, like box 1, whether the cat is behind you or not, then it can say no and the cat is behind the box 2. And now the cat can again move to box 1, and then you will again ask box 1 and you will find the cat. Okay. So let's increase our boxes and say there are 4 boxes. Now again, let's do the same strategy. Let's check it 2 and say it is not there. Then initially it was at either 1, 3 or 4. We are checking it again in the worst case that the cat is not here. So how many questions we can answer? So if it is box 1, then it can move to box 2. If it is 3, then it could have moved to 2 or 3. If the cat is at behind 4, then it can move to 3. Then again, it's your wish. You want to ask 2 again or 3. But because of the parity case, that order even, so we will ask at 3 and say not here. Then it was initially, let's say, not at 3 as well. So if it is initially not at now, sorry, initially, sorry, in the day 2, if the cat is not at 3, then initially it was not at 4. I should have written here 4 and not 3. It should be 4. Because if it was at cat as at box 4, then it can only move to 3. And if the cat is not at 3 now, then initially the cat, day 1, the cat was not again at 4. So, and it can only move to now 2 in both the cases. In 1 or 3, the cat has now moved to 2. So if it is not at 2, then it would have moved towards 1 or 3 or 1 or 3. Again, we have come again the same corner question. Then again, we will check it 3. If it is not there, then we will check it 2. And again, if you look at this is question number 1, question number 2, question number 3, question number 4. So we again have in the 4 questions we can answer this even boxes. Now, can you see any pattern here in the odd number of boxes, in the even number of boxes? I have already answered this. Can you see any type of pattern? Clear, ma'am, 1 or 2? Yeah, the 2 is the correct answer, Kanishka. Okay. Any more answers for this? The pattern? We can see any type of a pattern in the odd case number of boxes or even number of boxes. So let me again explain. If the boxes are 3, then we are asking whether the cat is at box 2 twice. And if the boxes are 5, then we were asking at box 2 first, then 3, then 4, and then 3 again, and then 2. Or maybe 4 and then 2 and 3. If the boxes, if the even number of boxes, then if there are 2 just boxes, then we are again asking 1 and 1. And if the boxes number are 4, then we are asking box 2 3, and then let me check once again. 3 and then 3 again and then 2. Sorry, what is 2? I'm asking the pattern here. I didn't understand 2. The number of questions I think you have written here 2, the earlier case. Yeah. The answer is 2 for that. We can find the cat in 2 to the 2 multiplied by n minus 1 twice if there are n boxes. And n is greater than or equal to 3 and all the boxes are in line. Okay. Okay, let's see other. Okay, there are no other answers. So any other? Way to find the cat, inspect all the boxes from 2 till n minus 1 and then check them again in the reverse order. Okay, so that's why you're saying 2 times n minus 1. So yeah, okay. So if there are no any other answers in 2n minus 2, then yeah, you are absolutely right that you can move to. This is the pattern. So again, you can see if there are 3 boxes, you are asking 2 and 2. So this is the middle one. And if you look at this one, if we provide 3 and 3, it is not working. But if you have proved from 2, 3 and 4, and then again to 3 and 2, then you would have find the cat. So this was a strategy we are using. We first asked 2, then 3, and then 4, and then again we are asking 4, 3, and 2. So these are the questions we asked. We first asked, this was the question 1 we asked, then question 2 whether the cat is at 3. This was question number 3, and then question number 4 again 4, and question 5, and this was question 6. And in the case 2, we were asking question 1 and then again question 1. Question 2 is 1, or vice versa, you can have asked 2 In this, we have asked question number 1 to 2, and then 3, and then again 3, and then again we have 4. And in this style, we have always cornered it to the cat again. So you are right. We will ask to 2 to n minus 1 if there are n boxes. And then again would have asked n minus 1 to 2. So this would have total 2 to the 2 times n minus 1 tries. And in this many number of tries, we have always found the cat. So this is the pattern which we are following. I hope this is clear. Whoever answered 2n minus 1 is right. Okay, so let's look at some. Okay, there are no doubts. So, okay, let's move to the next game, which is error detection, week 4. And this is a parity check. So, in this, the player 1 will come and they have multiple coins, let's say 16 coins with them, and they will put the coin is head or toss. Let's say we are saying head as 1 and tail as 2, sorry, 0. So the player 1 will come and put anywhere in this 4 cross 4 box any type of coins they want. So they will put tail, head, anything they can have put there, let's say anything. Now, what what you will do, you you have the option to add one more column or one more row and type your answers, like add one more column and one more row of the coins you want. So already this is the pattern which player 1 has come and put their coins in this fashion. Now, so now you will add one more column and one more row of coins however you want. So let's say I'm in how many ways I'm just saying, okay, let me just do this, and I'm just put this type of columns and rows. So I put tail, 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 and then head, head, and then tail, head, tail, head in this fashion. Now, player 1 will flip the coin, flip one of the coins in this 5 cross 5 box. And then we have to find that what cell the box have been flipped. Let's say the box have been flipped from this to 1. So now you will come and you have to find that this is the box which was flipped. So can you tell how can you determine this? So initially it was 1 and you don't know whether it was filled or not. So can you check, how can you check that this is the cell which has been flipped? Let's say I am going to flip this coin. Can you find a strategy? Can you find a way to communicate you that this has been flipped? Okay, let me just erase some of them and will ask randomly put values here. And then I will ask you whether which was flipped or not. Okay. Okay. Now I want to determine which cell has been flipped. Can you tell which row, which column has been flipped in this case scenario? Like, if I've given you this, which coin would I have been flipped? Did you understood the game? You can type any answer. It's I even don't know who is answering it. Third from right, fourth from top. Okay, so one has answered. Third from right and fourth. So you are saying this box. Okay. Anyone else? And if you want to explain why this is the answer, or anyone wants to try another one? Okay, so if there are no other answers, then yeah, I think you're right because we are not randomly putting these values, if you know that 0 1 0 0 1. So when the player 1 has come and given us this 4 cross 4 and given a setup of these coins that one is tail, one is head, so we will come and we will write one more column and one more cell and write the parity of it. So if there are two ones, so I will just say here 0. If I say, because there are even number of ones, this is a symbol. So if there are two ones here, again even number of ones. And if there are two ones here, again even number of ones. And there are odd number of one. So here it will be 1. So this is our understanding that in row 1, row 2, row 3 have even number of ones, and in row 4 there are odd number of one. And if in column 1 we will similarly do this. In column 1 there are even number of ones, here there are odd number of ones, even number of ones, and here are even number of ones. And if you see mathematically, this will be same for the column and the row. And let you find that why this will be same, that why this will be just one, and this is always well defined that from this and this side it will always be one. Now, since similarly which I have written here, now I want to check in this orientation which coin would have he had flipped. So if he have flipped, this parity would have been disturbed by something. If there are even number of ones, here is 0. So okay, in this case I don't think this has been flipped. If we again check in the second row, this is again even, so this have not been flipped. To check this, this is again even, this would have not been flipped. Now this is 1 1 and this is 1, but this should be even. This is even, so here it should be 0. But this is the bad case. So maybe the flip is in this, in this row. Okay, this is again 1, so we are fine with this. Now let's check at the column also. So this is even, so we are fine with this column. Since this is odd, so we are fine with this. Here it is just 1. This is odd, but here it is 0. So this is a bad case. And this is 1, 1 even, so 0. And this is 1, so it should be 1. So this is the, sorry, this is the bad case. Now, if we look at the intersection between this bad case and this bad case, it is this. So this must have been the flipped coin. So if we look at this again, we can also observe that this is the one which has been flipped. Here it is 1 and here it is 0. I hope this is clear. Or if you have any doubts, okay, let me ask you one question and you should tell me where the flip has happened now. I'm telling you the parity which you have given also to me. Okay. So initially I have set it up like this, and you have, sorry, I have in this, I have just flipped one coin, flip reverse one coin here, and you have to tell me that which one was the flipped coin. Yes. Okay. So now I want you to find where would I have flipped the coin in this table. The same way which we have done before. Can you find? Can write your answers in the Menti and I can check. There is one answer. Let's see. Middle row, second from left. Okay. Is there any answer in Zoom? One answer. You're adding the binary numbers like 1 plus 1. 1 plus 1 is not 10, it is 0. And 1 plus 1 plus 1 is 1. Yeah, it's basically a XOR sum. That 1 XOR 1 is 0. And 1 XOR 1 XOR 1 is 1. So odd number of 1 is 1, even number of 1 is 0. Okay, one of the answer is this. Middle row and second from left. Any other? or just okay. If there are no other answers, so let's check this. But still, you have any answer, you can write it there. And let's verify this also. So in the row 1, it is again ones or 1. It is 1, so it is correct. This is 1 plus 1 plus 1. This is 0. This is also correct. So 1, 1, 1, and it is 0. So this is a bad case because there are odd number of ones. So this is a bad case. And there are 1, and it's also here 1, so it's a correct. And this is 0, so this is also correct. And this is also 0 because it's an even number of ones. Again, this is a bad case because this is just 1 and this is here 0. And this is a okay, good case, and these are again odd, so these are again good case. But again 0. So this is the bad case, this is the bad case, and their intersection is this. So this must have been flipped. So the answer which he has given is middle row, second from left. So yeah, you are right. So this is the correct coin which has been flipped. Nice. Now, why does this even help in error detection? So when you put your answers in computer 0 and 1, so sometimes if you put it over Wi-Fi, sometimes it has not, because of error connection, because of stability, it has not given the full answer there. And there have been maybe the 0 has become 1 or 1 has become 0. So in this case, in this type of a scenario, you can always find where is the error have been. So this helped us because we can find the bad cases and then say, okay, this was the error. Okay, let's move towards impossible prison break. And in this case, there is already be a board of 4 cross 4 in which there are some tails and there is some, like there is some 0, there is some 1 0 1, there is some coin in behind of them. Or you can say there are some doors. Let's say there are doors. If the door is closed, let's say then it is 0. And if the door is open, then it will say 1. And behind all these doors, you will hide. So there are two prisoners. So there, prisoner 1 will come, and then you as a jailer will hide the key behind one of the doors. And you have to tell, let's say these are not doors because these are not doors. So just say one of the cells or one of the boxes you have behind. And now the other prisoner will come. So you have to just flip one of the coins or one of the cell from here. So you can either flip from 1 here to 0, or you can flip 1 0 to 1. So either thing, you can just flip 1 as a prisoner. You can only flip one of the cases here, and you have to somehow message the second prisoner that okay, the jailer who has hide the key is behind one of the doors. So the jailer will come and okay, let me start from here and again explain this because this has become a little confusing. So jailer is come and he has prisoner showed it to prisoner one that okay, here I'm hiding the key. And then the prisoner one, we can only flip one of the cases here. One can flip either 1 to 0 or 0 to 1, and somehow answer prisoner 2 that okay, here's the key where it is behind, and if you can find the key then we can escape from here. So to solve this, you have a communication between the prisoner 1 and prisoner 2. So since you can see that it is a 16 square 4 cross 4, so there are 16 cells here total, and in one of the cases behind uh, you are saying the key is hiding. So So because it is 16 and you know the binary that 2 to the power 4 is 16, so you can represent each boxes by these 4 bits. So you can represent the box 1 by this 001. This you can represent as 001 and 0010 and 0011. And similarly, you could have expressed these type of boxes to everyone. So you have given a binary number to everyone. This is box 0, decimal box 1, box 2, box 3, box 4, box 5, box 6. So it's in decimal and you can write the similarly in the binary way. And you are encoding these type of uh, secret code using by telling what will be your first bit, what will be your second bit, what will be your 4 bits. So this is how you will present. So in the current case, let's say what as a binary system, as a decimal, you are telling it to the second prisoner that here is the key hiding where. So the first key we are saying that if you XOR the sum of these last 2 rows, this will be the this will be your first bit. So if we look at the last two things, there are 1, 2, 3, 4, and 5 odd number of ones. So the first bit we are representing it as 1. If we look at the second bit, we will take the XOR sum of the second row and the fourth row, which is this and this. So there are 1, 2, 3, three number of ones. So it will be again 1. And the third bit is the last two columns. So this is last two columns. 1, 2, 3, 4, 5. So there are 5 ones here. So it will be again 1. And if you look at the fourth bit, it will be 1, 2, 3, 4, 5. Again 5 ones. So it will be 1. So the final number of bit you are telling it to it is 1, 1, 1, 1. So what is it in the binary? Can you tell? Anyone? What this is in the binary? Oh, sorry, in the decimal system. This is in the binary. Can you convert this into the decimal? Second from left and third from top. Yeah, Sanjeevani, you're right. Anyone? 1, 1, 1 is in decimal. Okay, let me, because I think we are over time. So let me just tell what is 1, 1, 1. It's in 1 into 2 to the power 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2 plus 1 into 2 to the power 3, which is 1 plus 2 plus 4 plus 8, and it is 15. Now, the question which I want to ask, and you should do it as your homework, and we will resume it from here. So, if you hide the key at 15, then where will you flip the coin? Let's say the jailer has put the key in behind this box at 15. So, which cell you have flipped in this case so that you can tell the jailer that it is at 15, and currently it is at 15, and you want to tell the jailer is it at 15 again, and you have to flip it. So okay, so this is the question, and we will resume from here in the next class. Thank you for joining. If you have any doubts, whoever have any doubts can stay and ask. And if you don't have any doubts, you can go because this is the end of the session. You can ask in the Menti or in the Zoom. You're right. This is 50. And if you have doubts, so ma'am has presented them with some good demonstrations. So you can watch the videos and understand from there, because I don't have I have restrictions of demonstrating them, but you can go ahead and look at it. Okay, if you don't have any doubts, I don't see any doubts. So okay, let's thank you all for joining, and this is the end of the session. Okay, let's stop here.